on stoichiometry and glass batch lab. So you'll notice at the top we have the periodic table of elements, and it starts with a problem. It says, given the following equation, 1 mole of copper plus 2 moles of silver nitrate yields 1 mole of copper nitrate plus 2 moles of silver. And it says how many moles of copper are needed to react with 3.5 moles of silver nitrate. Since there are no grams in this problem, all we need is the balanced equation. So I'm going to start with what I'm given in the problem, and I'm going to put that here. 3.50 moles of silver nitrate. Now, from the balanced equation, I'm going to get my mole to mole ratio. So if I go back to the balanced equation, I can see here that I have 1 mole of copper. The one's not written because chemists are lazy, but it's implied because if I had more than one, it would be stated like here for the 2 moles of silver. And if I didn't have any copper in this equation, if that coefficient was a 0, then the copper wouldn't be written. So we assume 1 mole there. So for my balanced equation, there are 1 mole of copper and 2 moles of silver nitrate. So these numbers just come exactly from my balanced equation. Then I'm going to multiply the top, divide by the bottom, and that will be my answer. So in your calculator, you're going to want to take 3.50 divided by 2, and you will get 1.75 moles. Okay, notice that moles of silver nitrate cancel, so I'm left with moles of copper. Anytime I do a stoichiometry problem, I always start with what I'm given here in the problem, and those units go on the top left. These units always waterfall down to the next column, but on to the bottom. So they waterfall down, and then the units will always drive the math. Let's try another. Same balanced equation, but different problem. How many moles of silver can be made from 4.23 moles of copper? So where am I going to start? Always 4.23 moles of copper. I'm going to start with what I'm given. Notice I started with moles of copper because those are the units on the number given to me in the problem. Those units waterfall down to the next column, but on the bottom. And then on the top, I have the substance that I want to find out about. And then I go back to my balanced equation and plug in the numbers. From my balanced equation, I have 1 mole of copper, so I know this is going to be 1, and I have 2 moles of silver. Moles of copper cancel because anything divided by itself cancels or gives us 1. So then I'm going to multiply the top and divide by the bottom. 4.23 times 2 gives me 8.46, and the units will always be the units here that did not cancel. So just to kind of go in depth a little bit more about why these units cancel, it's kind of like reducing a fraction. If I had 5/10, right, could be written as the same as 5 divided by 5 times 2. And then the fives would cancel, and I would be left with 1/2 because 5/10 is the same as 1/2. Same thing here. Anytime I have moles of copper in the numerator and moles of copper in the denominator, they cancel each other. In chemistry, we call these conversions because we're not changing the amount of substance, we're just changing the type based on our mole to mole ratio. So, the great thing about stoichiometry is it allows us to figure out how much of a reactant or product I will need or I will make based on what I have. So, if I look at this problem, it's telling me I have 4.23 moles of copper, and I want to know how much silver I can make with that much copper. So it's kind of like a recipe. If I was going to make chocolate chip cookies and I knew that I had 10 cups of flour, how many cookies could I make? This stoichiometry is the exact same thing, but instead of cookies and chocolate chips or cookies and flour, I know that I have 4.23 moles of copper, and I want to know how much silver that will give me. Stoichiometry is just a recipe for chemistry. All right, let's look at another one. So it says, giving the following equation, again, the same equation, how many grams of silver can be made from 5.5 moles of copper? So again, this is the only number I'm given. I'm going to take this number and its units and start my train tracks there. This will go in the top left. So I know that I have 5.55. That is the only number I'm given to me in the word problem. So I know that's where I'm going to start. It goes in the top left-hand corner. You can see I've already waterfalled the units down for you because we don't want to know anything about copper. I want to know how many grams of silver I can get. So these units will eventually cancel, but then I'm going to go to my balanced equation. Notice I have a mole to mole ratio. In my balanced equation, I have 1 mole of copper and I have 2 moles of silver. So I'm just going to fill those in from my balanced equation. And then I'm going to again go this time instead of stopping at moles, I want to know how many grams of silver. So this is combining the stoichiometry step with one more step. Instead of going to moles, I'm going to go to grams. This is important because when we're in the lab, I don't have a molimeter. I don't have something that can measure out moles. I need to convert to grams so I know how much to weigh out into the lab. So here from the periodic table, if I scroll back up to the top, and if I go to silver, Ag, I can see that silver has 107.87 grams per mole. So let's just go ahead and round that to 108. So I know that there are 108 grams of silver per 1 mole. Okay, this step will always be 1 mole because 1 mole of silver has 108 grams per the periodic table. The only time you use more than 1 mole is when the numbers come from the balanced equation. Now, I'm going to multiply everything on the top and divide by everything on the bottom. If you notice, everything on the bottom is just a 1. Anything divided by 1 is itself, but we would take 5.55 times 2 times 108, hit enter, divide by 1, and then divide by 1 again. And I will get that from 5.5 moles of copper, I can make 1,199 grams of silver. In my calculator, I have 1,198.8, but I just rounded up to the whole gram. We don't do significant figures in material science, those of you that have had chemistry. All right, let's try another. Okay, so again, same balanced equation. And it says how many grams of silver nitrate could be produced from 23.1 grams of copper. So this is my number given to me in the problem. That's where I start my train tracks. That goes in the top left, 23.1 grams of copper. Okay, these units are going to carry down or waterfall down. Okay, and then I know that for 1 mole of copper, if I go back up to my periodic table, I can see copper has 63.55 grams. A lot of times in chemistry classes, you'll see them keep that at 63.5, but let's just round up to 66 grams of copper per 1 mole. Okay, that step's complete. My grams of copper cancel, and now I'm in moles of copper. Now that I'm in moles, I can do my mole to mole ratio and get from copper into my silver nitrate. This is the only step where our numbers come from the balanced equation. If I look here, I can see that I have 2 moles of silver nitrate from my balanced equation and 1 mole of copper from my balanced equation. And then my last step is for every 1 mole of silver nitrate, how many grams do I have? So let's just make ourselves a little list. Silver, I have 1 of them, and I know it has a mass of 108 because I just did that in the last problem. 1 times 108 is 108 grams. Then I have nitrogen. I have 1 of them. And then I have 3 oxygens. So let's just cruise on up to my periodic table. And I can see that nitrogen right here has a mass of 14 if I round to the nearest whole number. And oxygen right next to it has a mass of 16. So nitrogen times, I have 1 of them times 14 grams. 1 times 14 is 14. Oxygen, I have 3 times 16 grams, which is 48 grams. And then I'm just going to add all of those up together. So in my calculator, I'm going to take 108 plus 14 plus 48, which gives me a total of 170 grams per mole. And then I'm going to put that here, 170, oops, this should be grams of silver nitrate, not moles, because I already have moles here. Look, these units waterfalled here. And I know that there are 170 grams per 1 mole of silver nitrate. And again, I'm going to multiply the top, divide by the bottom. So in my calculator, I'm going to go 23.1 times 1 times 2 times 170, enter, divided by 66, enter, divided by 1, enter, divided by 1, enter. So that will give me 119 grams of silver nitrate. Now, in your calculator, if you didn't want to have to hit enter after all the division steps, you can multiply everything in the top and then put one set of parentheses in the bottom with a multiplication in between. So the other way to do this would be 23.1 times 1 times 2 times 170, enter, and then go divided, parenthesis, 66 times 1 times 1, close parenthesis. And that will tell your calculator that you want to multiply everything in the numerator and divide that numerator by everything in the denominator. All right, let's do one more example. So it says how many grams of water can be made from 2.23 grams of hydrogen? So this is the only number I'm given to me in my problem. So I'm going to start there, 2.23 grams of hydrogen. Okay, look at my balanced equation, and I know that hydrogen is diatomic. So H2. These units are going to waterfall down. I want to go to moles of hydrogen gas. And then once I'm in moles, these units are going to waterfall down. That will give me moles of water. Oop, okay. Because I want to go to moles of water, because once I'm in moles of water, then I can go to grams of water. Notice how I set up all of my skeleton of my train tracks before plugging in any numbers. This will help you from making silly mistakes. So now I go back and start filling in my numbers. I know that there are 2 grams of hydrogen per 1 mole because I have 2 hydrogens and each of them is 1 gram. Then I'm going to go to my mole to mole ratio, and I can see that I have 2 moles of water and I have 2 moles of hydrogen. So I'm just going to plug in those numbers here. And then I know there are 18 grams of water per 1 mole of water because hydrogen, I have 2 of them. They are each 1 gram. That gives me 2 grams per mole. Oxygen, there's 1. 16 grams per mole, 2 plus 16 will give me 18. So now let's put this in our calculator. We're going to start with 2.23 times 1 times 2 times 18. Enter. Divide, parenthesis, 2 times 2 times 1, close the parenthesis and hit enter. And from 2.23 grams of hydrogen, I would be able to make 20 grams of water. I hope this helps. Have a good luck and come to a help session if you need more help.